Welcome to MatheNatic. We are revising statistics for grade 12 mathematics. So let us jump into our example. The following table shows the age of 8 fossils of a particular species found in South Africa and the volume of their skulls. So in our table, the first line, we have age in millions of years, and that's indicated with an X, and the volumes of their skulls. For our next question, we are going to determine the correlation coefficient. And for this question, you can use your calculator once again. And the calculator that I prefer to use is the white Casio calculator. So let us quickly run through the steps. First, I'll press Shift 9 to clear the calculator's memory. Then I'll press Mode and a few options will pop up, and I choose the option that says Stat. Then another few options will pop up, for example, 1 minus var, and a plus bx, and a few others. So you need to choose this option where it says a plus bx. Then two columns would appear. You'll have an x column and a y column. Now it's important, when you enter the x values and y values, they need to correspond with each other. So the first x value is 2.4. Then the first y value must be 38. So please take your time when you enter the x and y values on your calculator. Once you have entered all the values, you press AC and your calculator screen would clear. But now that information is stored within the calculator's memory. So all that we need to do now is press Shift 1 and choose the option for the regression line again. And one of the options is R. So option 3 would be R, and you press equals. And the value that will pop up is your correlation coefficient. So the correlation coefficient for this data is negative 0.96799, and you can round it off to negative 0.97. And our last question for this video is to discuss the correlation. So what you need to know about correlation is that the value will fluctuate between 1 and -1. So in order to discuss correlation, we would use the correlation coefficient. So here we have it as negative 0.97. And we would say that this relationship is negative because we have a negative value. And we'd say the value is strong. So therefore, the relationship is a strong negative relationship. Let us quickly recap what these values mean. So if your correlation is 1, that means the data points are on a straight line and it's an increasing line. So that means all of the data would fit exactly on the regression line. If it's 0.9, if I have my scatter plot, then you can see the data is really close to a straight line. So a few of the points will be slightly off of the regression line. Now for a value of 0.5, we will have the data slightly more scattered, and you can see some sort of pattern, but can you see the spread around the regression line is a little bit wider. So now we'd say this correlation is moderate and positive. For 0.2, we have even more of a variation of the data, so the data is even wider split. And this is a weak correlation, but it's still positive because we can see it has an upwards pattern. When your correlation coefficient is 0, then you can't see any pattern within the data. So the data looks scattered and quite random. So we can't spot any pattern. Now for -1, your data would be decreasing, but it will be exactly on a straight line. So all the data points would fit on the line of regression. So this is then perfect negative correlation or relationship. For 0.9, you can still see that the data is going downwards, and they are quite close to the regression line. So you can see almost a linear type pattern forming. For 0.5 or negative 0.5, the data is slightly more scattered, but we can still see the downward slope. So we say it's negative, but this relationship now is moderate. And for negative 0.2, data is split wider apart. So you can see there's a bigger spread between the data and the regression line, but we can still spot some sort of negative pattern. And that is how we interpret correlation. Thank you for watching. Remember to show your support by hitting the like button and subscribing to MatheNatic.